Hello, welcome to session number 5 in the series Programming Languages. In session number 4, I introduced you to various data types, and these are types are nothing but they are class objects, right? And we also looked at string, which is stored in a heap in a string pool, and we have seen another form of storage which is called stack, and we have seen registers which are part of the memory map, uh, which are used by the processor to perform various operations. So there are different levels of memory which we are talking about: registers, stacks, and heap. And inside the heap, then we were talking about string pool. All the types are on the heap, are created on the heap, right? And then we were talking about various primitive types here, right? And what are the various sizes, and which ones can be casted to to uh, other ones, and which ones have to be explicitly casted by a programmer. So we talked about two concepts: one was widening, other was narrowing in casting. Then we also talked about various operators and their precedences, right? And then we have discussed how to use these operators where they're used. We also talked about various branching statements and loops or iterative statements, and we also covered a little bit of graphical programming. Now in this session 5, we are going to talk about types, not all the types but some of the types. So what do you mean by type? So there are 5 types, right? So these 5 types we are going to talk about. So first is the object or a class, right? And then there is something called structure. Then there is enumeration, and then there is delegates, and then there is a interface. So there are 5 types which are used in C, and these 5 types we are going to talk about one by one. Class, we have seen how to create a class, how to instantiate an object, and uh, various properties or pillars of object oriented programming, right? We have seen that in detail. The structure is nothing but a lightweight class. Now class is referred by its reference or address, while structure is a value type. So basically, when you equate uh, when you equate uh, objects, you are basically equating their addresses, while in case of a structure, right, you are creating a copy. So for example, usually these concepts will arise when you pass an object to a method or a structure to a method. Then you will see the difference between the two. Enumeration is basically its base type is an integer, a byte. It can be long, it can be a short, right? So these are integer types, right? But they are referred by a name, right? So these are called enumerations. And what do they bring to the table? Enumerations improve the readability of a program, readability of the logic, right? And these enumerations can also be used in branching statements, right? For example, a switch statement can be based on enumeration because the base type is a integer. Delegates is basically tying methods to a certain signature, and you can basically, they are pointers to a method, right? So you can call a method using its pointer. So that's what the delegates are. An interface is a contract. A contract, when you are writing a class, when they subscribe to one or more interfaces, then these interfaces have got certain methods which have to be implemented if they subscribe to that interface. So a class can inherit from numerous interfaces, right? While a class can extend another class, but a class can subscribe to number of interfaces. So unlike Python, where a class can be derived from multiple classes, it's not possible in C# to do that. A class can be derived from a number of interfaces. That's possible. Okay, so we will talk about this later on. So let's get started with doing the things. So let me just bring up Visual Studio. So first of all, I'm going to show you some of these types. Like for example, I'll to show you enumeration. Right now, I can create a class inside a class that will be called an internal class. I can create a structure inside a class. I can create an enumeration inside a class. But these are all at the same level, right? So basically, these can reside in the namespace, but they can also reside into each other, right? So a class can also have a class inside, so that is called an internal class. Okay, so similarly I can create a structure inside a class, right? But uh, they are at the same level. They can be created inside a namespace. So okay, so let it come up. Okay, a simple note, when you use a value type, or when you pass a value type to a method, uh, a new copy or a local copy of that value type is passed on to that method. The original uh, type which is involved in calling is not modified. Its copy is created, and that local copy is worked upon inside a method. So that is called passing by value. Now in case of a class object, the 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 pointer to that object is passed to the method. So if you do something to that method, something to that object, then that is reflected in the object which is passed, the reference of the object which is passed. So the original object gets modified, right? So this is called passing by reference. Okay, so let's create a new project, and it is going to be a console application only. So it is going to be a console application C#, and say next. And here I'm going to call this as lesson 5, and I'm going to say next, and I'm going to say do not use top level statements because I want to see the entry level main and all that, right? And just say create. So I'll show you a number of concepts in here, right? So first thing you have to keep in mind is the structure is similar to a class. You can call a structure as a lightweight class, right? But the difference is that the class objects are passed by reference, while in case of structures they are passed by value. So any type has got the fields which we have talked about, and the methods, right? And also the properties which you created last time, right? So all these things which are created inside a class, as a class member, they can also be structure members, right? So structure members can be fields or the data variables. They can be properties if you want to create properties. They can be constructors, right? So all this is possible inside a structure. So let me just show you. Okay, let me. Okay, so here we have got a class called program in a namespace here. Now the structures are at the same level as the class, right? So I can say struct. Okay, and then I can say, let's say a rectangular coordinate system, I can say rect. Okay, so this is same as a class, but it is by value, right? So I'll tell you what it means. Then I can say this. Okay, so this can have two, any rectangular coordinate system. Okay, we have got two coordinates, x and y coordinates, or in a three-dimensional system there are going to be three coordinates, x, y, and z. So let's say we are dealing with 2D, and rect represents a rectangular coordinate system point, right? So that point is going to have a float. Well, I'm not going to use float, I'm going to use a double, because it is not CLS compliant, and then whenever you pass them there will be an issue. Okay, and then I can also say comma y. Okay, so I have x and y which are public, right? You can make them private also, but for simplicity let's leave that out. We just create everything public. Okay, so now if you create this, there is a default constructor, right? That default constructor is very easy to call. So for example, if I say rect p1 is equal to, rect p1 is equal to new rect. So this is the constructor which is a default constructor for this structure, which is the same as the constructor for a class. Had this been a class also, it would have worked, right? But again, I told you, class is a reference type while structure is a value type, and this default constructor is there in both cases, but there is a difference. Okay, I'll tell you what's the difference. Whenever you create a value type, there is a memory which is allocated as soon as you create it. Okay, you have to allocate the memory, right? So for example, let's say, let's turn this back to structure, and I'll tell you the difference. Okay, so it is doing that. Now let us just put a constructor of our own. So we will say public, and we'll say rect, and then it is going to receive a double, and x comma double and y. So this is the constructor, and this constructor is going to assign this. So you see that this is red color, which means that it is incomplete. So I can say this and y. So now this is a constructor which for this structure. So now the default constructor is still there, right? Okay, so there's nothing wrong with this. Okay, or if you want to be on the safer side, you can create a default constructor. You can say public rect, right, and then you can say a default constructor. Now it is binding for the default constructor to do the assignment. So I have to initialize it, because as soon as you create a structure, the memory is allocated. That means that in the first constructor the memory is allocated and the values are assigned, but the second empty constructor, the value has to be assigned, and this can be initialization, which is 0, and then you can say y is also 0. So now I have got two constructors for this structure, right? One is the constructor which receives x and y, the other one is the default constructor which will assign 0 or initialize it. Now if we do not do this, right, for example, okay, then you see that there is a red line which says that there is something error, and if we say rect must be fully assigned before control is returned to the caller, right? This you are seeing because this is a value type. and the memory is allocated beforehand as soon as you do this new rect. And this means that the value is not initialized. It has to be initialized to something. Had this been a class, then this red line will disappear. You see here, red line disappeared. That means that these are now referring to null. Okay, so if you use a default constructor like this, then x and y are referring to null, right? Because this is a reference type, right? But if this is a value type, which like a structure, then they cannot refer to null because the memory has to be allocated, right? So in that case, you would have to initialize it. So I hope you understood. I hope you understood why I had to initialize a value in case of a value type. Okay, while I don't have to do this in case of a class, because class is a reference type and the data fields can point to a null location, while in a structure it's a value type. It is created at the time of instantiation, and then the memory is allocated at that time, and that means that the variables have to be initialized. They cannot point to null. So that's the difference between value type and a reference type. Okay, so we have done that. Okay, so we have created one first one we have created using a default constructor. The second one we can create using 2.3 comma 4.2, let's say. So second one, we have instantiated the structure using a first constructor here. Okay, so this is using the one of the constructors here, and this one is using that. Now I can also do this. I can say p1 because it's a public data field. So I can say p1x is equal to 2.2, right? And I can also say p2, oh sorry, p1y is equal to let's say 3.2, right? So I constructed the structure with the default value of 0 for x and y, and then I have assigned x and y. So this is how I have instantiated a object of a constructor. Similarly, here I have instantiated an object of a constructor using object of a structure using this constructor where I provide the values here. So this being said, okay, let's see what other things can a structure hold. A structure can also have a method, right? So this constructor is one of the methods. It's a special kind of a method which doesn't return anything. It can receive arguments, but it doesn't return anything. Now there are other methods possible. So let's say if I want to add 2 points, p1 and p2. So let's overload an operator, right? So that's a concept which is just like a method, right? So I can say here, so all this, okay, so let's do this. I can say public, then I can say so I'm going to overload a operator, right? So it is going to return the same type after addition. So it's going to take two points which are of type rect, and then they are going to add x to x of the two rects and y to y, and return the type which is again a rect. So public rect, and then I can say operator, and that operator I'm going to overload is called plus. So this is same concept as polymorphism, where I'm going to overload an operator, OPERA, overload an operator plus. Okay, and here I can pass on two arguments. So this is I'm overloading a binary operator, right? So I need two operands, rect, let's say A comma rect B, right? And what is it supposed to do? It is supposed to return a rect right? So it is hinting me what it is supposed to do. That's all what it is supposed to do, right? Okay. Now here this is still showing red. Okay, it says op addition does not access instance data and can be marked as static. Okay, okay. Okay, so basically it means that this is going to be a member of the class, the structure, not a member of object of that, right? So do I want to do that? Hang on, let's see if there is another way of doing this. Let's say rect c is equal to new rect, right? And then I can say c dot x is equal to a dot x plus b dot x, and then c dot y. I'm trying to know if this has to be a static. Return c. I think it has to be static. Is there a dot here? It says user defined operator rect must be declared static and public. Okay, member of addition does not access instance data and can be marked as static. Okay, so that means that either way you will have to do a static here. Okay, so having done that, let's see if it can do the addition, right? So this thing could have been written in a single line, right, as I have done earlier also. Okay, so there's no need of creation of this object. It is created and its pointer is returned here by new, right? So new rect, because there is already a constructor which allows you to construct like this, then you can say a dot x plus b dot x comma a dot y plus b dot y, right? So this is also fine. Okay, so then I can do p1 and any binary operator will work, right? So I can create a new one if you want. I can say rect p3 is equal to new rect. I can create an empty one, and I can say p3 is equal to p1 plus p2. So this is called operator overloading. The plus operator has been overloaded to do this addition. So x is added to x and y is added to y for p1 and p2 and the result is returned in p3, right? So here what do I want to do? Okay, so this is possible. What about another way of doing this? I can say rect p4, okay, and new is created right in the return statement. So I can just write here plus, sorry, I don't have to create it. I can just say p1 is equal to or plus equal to p2. Now when I do this, the pointer which is returned to p1, okay, the original pointer which is returned to p1 is over here, right, and that is being replaced by a new creation of a rect here, which is that, and that is being returned to p1. Now p1 has a different point, is pointing to a different location which holds the addition of p1 and p2, right? So now the question is, we want to see the results, right? So as soon as p1 and p2 are created, I can write here console dot write line, and I can put here a statement for the first point I want to display it, right? And here I can say P, and I can just put here X and Y, sorry, comma. So I can put here P1 dot X, and I can put here P1 dot Y. Okay, so I'm displaying 0.1 as P, so it will come out as 2.2 and 3.2. So let's just run this build solution. Okay, it's build, debug, start the debug. Okay, so it says P 2.2 and 3.2, right? So this is first point. Let's put here the second point. Control C, Control V, and here let's put P2X and P2Y. So these two points are input, and then here I am adding them and returning the value in P3. So I'll have to do P3X and P3Y. P3X, sorry about this, P3Y, right? So the addition of the two is returned in P3, which is displayed here. And after this, I'm going to display back P1 again to show you that now P1 is pointing to a location which stores the sum, and I'm going to show you the sum. Okay, so build solution and say debug, start without debugging. So you see here 2.2, 3.2, 2.3 and 4.2. So if I add these two, it is going to be 4.5, and if I add these two, this is going to be 7.4. So the result is 4.5744. That means that this operator overloading is working correctly. Now can I do another operator overloading, which is minus? So I can say static. I can do plus, minus, multiply, divide. I can overload any unary or a binary operator. So there is nothing special in here. Operator, and this time I'm going to overload minus operator. Okay, so this is being done. And of course it is complaining there has to be a return type. What's the point here? New rat. Let's just repeat the same thing, which will be, again I have this thing, so I can say a dot x minus what, a dot and oh, spelling mistake, operator. Now it will not do a problem. A dot x minus a dot y. Okay, comma, sorry, a dot x minus b dot x, b dot x. So I'm subtracting b from a, comma, a dot y minus b dot y. Okay, so I have overloaded a minus operator, right? So first of all, I'm not going to do anything. I'm going to just see what 0.1 stores now. So 0.1 will be again, now P1 is now referring to a location which stores the sum. Earlier P1 was pointing to 2.2 and 3.2. Now P1 is pointing to that. Am I right? Yeah, so let's just build this. Build solution. Start with that. So it says 4.5, 7.4, 4.5, 7.4. So now P1 is now this one, and P1 earlier was 2.2 and 3.2. Okay. Let's get to that concept again. If I assign the addition to itself, then the value should be copied because this is a value type, right? So value should be copied into P1 and P2. P1 should still point to the same location as P1 over here. It's just that its content would be changed. So that is by passing by value. If it was a class, then this would have resulted in pointing to a different location. So my bad here. Okay, so that's being done. Okay, so what have I shown you? I have shown you that I can create methods inside a structure. I can create constructors inside a structure. I can have fields inside a structure. A structure is same as a class, right? So if I was to replace this with a class, it is going to mean the same thing. So if I replace this with a class, it is going to mean the same thing, right? It's mean the same thing. It is going to run the same way. But then here, something assignment like this, I am basically working with their pointers rather than with their values, right? So that's what it means. So let's say I build the solution, and if I debug it, so it's the same result. So the question here is, if I was to use a class versus if I was to use a structure. So where do you see that difference, right? So we will come to that in a second. Okay, so let's turn this back to a structure. Okay, so now can I write other methods? Like, for example, this is I have overloaded operator plus and minus. What if I was to give a method which can add n number of points? Okay, so I can create a static method. Okay, a static method here I can create, which is again a public. Okay, so this is a class member. Whenever I say static, it is a class member. So a racked dot operator would work on it, right? So just like overloaded operators, they are static members. I'm going to create another static method here, which is called public, and I'm going to call this one as add. Correct? And here I am going to pass n number of points. Right, so I want to say, how do I pass that? I can pass that as an array. So I have to say params, and then I have to say racked, and it is an array which I am passing, and it is a. Correct? And it has to return a type, sorry. So it has to return a type racked only. Okay, so here I can do the maths. So I can say racked, I can say C. So C equal to new racked. So I'm using an empty constructor with initialized value of 0, right? And then I can say for each, because this is a I enumerable, any array is I enumerable, so I can say, I can use a for each racked R in A. So I am going to do the summation. I can say C plus equal to R, right? And then I can say return C. Okay, so let's see this method which I have written. It is a static method, so it belongs to this type. Okay, racked. It is not a member of an object. It's a member of the structure or a type. So static, public, it's public. Racked, it returns a same structure, racked. Okay, so a pointer to a racked. So and then it says add is the name of the function, and then it receives n number of variables, right? N number of variables here, and this n number of variables is an array of the same type rect. So this A is a array of rects, and then I'm doing a first element as, you know, the one which has initialized x and y as 0, which is created by this constructor x equal to 0, y equal to 0. And then I'm doing, as the plus operator is already overloaded, I can say c plus equal to r. So that means that loop through all the r's, all the rects in this list, and add them together and return the value as this. So now I am going to get rid of this guy, okay, or rather I'm going to get rid of all of them. Okay, so I have created rect p1, p2, then I'm going to create p3 equal to new rect. Okay, and here I can create another rectangular coordinate system, another point, which is basically 5.6 comma 1.2. How's that? Okay, so now I have got 3 points here. Now I have to add all 3 of them. So I have overloaded this plus operator. I can do a plus here, okay, but then I can just call this method here, okay, which receives array. So I can just say I can say rect p4 is equal to, let's just do a new rect, right? And then I can say p4 is going to do is going to receive an addition. So now this add is a class member, so I can access this using this, and here I can add a list. Here I can add a p1, I can add a p2, and I can add a p3. Okay, and that's it. So what's going to return in p4? What's going to return in p4 is going to be this. Now this line is basically useless actually. This line could have been done in just one statement here, because return the C is pointer is generating that that object of that type. So I can just say here rect4 is equal to this. So this works. So now here I have got 3 points, and then I'm adding all the 3 points into a 4th point, right? So this is using a method which is a member of this class. But then something interesting which I'm doing here is I can put arguments as an array, and that is basically represented by this what is called params, which is referring that what you are passing is a comma separated members of this array A. So these are comma separated members of this array rect A. So basically this p1, p2, p3 are packed into an array of rect which is called A, and then passed on to this this method. So this is, I'm passing this, and then I'm adding them, and then I'm returning a rect which is a C, and which is I'm assigning to p4. So let's just do a console.write line on each one of them. So I can say console, or rather I will write a method to print it also, right? Another method to print it. So let's do another method which is again a member of the class. So I can just say it is a static and it is public, and what it is doing is it returns nothing, but then it is going to do a display, because every time I don't want to write it, so it is going to display, and I'm going to say params. So as many as I give the inputs, and it's a rect, and it is a array A, right? And here I'm going to say console dot write line, and here I'm going to display this p. So this I have to do for all the members of the array A, right? So I can have put here for each rect r in A. I have to display them console.writeLine p. So this refers to a point, and this has got two values, x and y, of r dot x and r dot y, and that's it, isn't it? Right line spelling is wrong, right? Okay, so what is this method going to do? It is going to receive an array, and whatever is inside that array, it is going to print. So for example, I can display here, I can just say rect dot display, and I want to display what? P1, P2, P3, and P4. Done. So see how concise the code is. Now the thing is, you can see what is the advantage of calling a method. Calling a method basically is a block of code which is to be repeated again and again. So you put it as a method and you just call it as many times as you like. Now there is, whenever you call a method, what happens internally is this is like a soft interrupt or a exception, not a exception, you can call it exception. It is a soft interrupt or exception. It says that processor, whatever you are doing, stop there and back up everything onto a stack. And now I'm going to assign you or delegate to you a new work to do. So you do that first, and then once you are done, you resume your operations. So let's see what it means. So I'm telling the processor, whatever you are doing, stop there. Okay, whatever is your bookkeeping, whatever is in your registers, okay, put it back onto a stack. Okay, and now I'm going to give you a new thing to do. Just do that first. So once you are done with it, okay, then you come back and resume what you are doing, right? So this is when you call a method, this is the algorithm. So now what happens is, if you call a method, it is less efficient. Why it is less efficient? Because everything is being backed up to a stack, and then once the interrupt is, or the soft interrupt is executed, now the program control returns back to the previous program. So everything from the stack is put back into the registers, right? So this is an additional operation which you are doing whenever you call a function. Now when you call a function inside a function, which is called recursion, right? So it depends on how deep is the level of recursion. So if you keep on calling functions after functions, at some point the stack is going to be full. So when the stack becomes full, now the stack is contiguous. That means that there is a data stack and then there is a program stack on the same memory map. So if you keep calling the function recursively, the stack, which basically grows downwards, okay, is going to go and corrupt the program stack. The data stack is going to corrupt the program stack because they would overlap. So this is called segmentation fault, right? Is there a warning against that? Yes, there is a warning. That's called a segmentation error, right? So whenever you call a function, you have to be judicious. If you call it recursively, you have to be very careful because you might run into segmentation faults, okay? Or whenever you call a function too many times, okay, it can cause the stacks to overflow. Okay, so it can also say, oh, Stack Overflow. Okay, so that's the same problem. Okay, so that's the problem of calling functions, right? The advantage is you can repeat the same code again and again without typing it. You just call them by name. Now, what is the advantage? What is the basically what is the loop around for this problem of Stack Overflow? The the loop around would be something called inline methods or inline functions, where whenever you call an inline method, the compiler gets an instruction that include the same piece of line again and again, right? Same block of code and again. So this is done at the compiler level, not at the processor level. So when you do something at the compiler level, then you have all the advantages of the you have all the advantages uh, of a function call, but then you are not running into stacks. Okay, your compiler is handling in inline functions. So I hope you understand what I mean by inline functions. Okay, so now you can see what are structure, what is a structure, and you can see how to construct a structure, and you see how to overload the operators. You see how to define methods, and you have seen how the method basically uh, receives uh, receives the argument list. So this is called an argument list. Now, can I overload this method? Okay, so what do you mean by overloading? Well, I am going to do a polymorphic form of the same method, right? So can I do that? Well, yes. So what will it differ? It will differ in the signature of that method. What is the signature of the method? The signature of the method is the name of the method and the argument list. So it has to differ in the argument list, right? So let's say, okay, let's say I am going to do a method which is not a class member. Okay, let's say I am going to do a method public, and then it's not going to return anything, void, and then it is going to do a sum, and now this is a method of the object, not the class. Okay, it is going to receive rect two operands, rect A and rect B. Okay, now question that comes is, I am returning a void, so how am I going to get the two additions, right? So there are two ways of doing this also. Okay, so one method is you can put here a out, a rect, and then I can call this one as S. Okay, so now you see what's happening here. There is this is passing by, so this is basically just declaring, this is just a placeholder. Okay, it has no information what it is doing, right? So now the S is not assigned anywhere, so I have to create first a rect S, or rather I don't even have to do rect S. Can I do S is equal to new rect? Okay, and then the value has to be returned in out variable called S, right? And I'll show you what is the advantage. The advantage is the method can return only one variable over here, right? Now here it is returning void, but it can return only one variable. But if you use out, you can have as many out variables as you like. So basically a method can return multiple values, right? Now out rect S is just a placeholder. S doesn't exist. Okay, S doesn't exist. It is created over here, right? So it is created over here, and then I would say S is equal to A plus B. Sorry, A plus B. Okay, so there is no return here because the return type is void. So S contains A plus B. So how would I do this? I can just say rat P5. Okay. Do I have to do that? No, I don't. I can just directly call it. But then this is a member of one of the objects, right? So you can use any object if you like. I can use P1, for example. P1 dot sum, because I'm passing the two, so don't get confused. I'm calling a member of an object. Okay, rat sum, and here I'm going to do a out rat P5 comma P1 comma P2. Right. So now what is returned in P5 is the sum of 1 and 2, which also P3 also P4 also has the sum, right? P4 has the sum of 1, 2 and 3, and P5 has sum of 1 and 2, right? So I can move this line to the bottom and say I want to display P1, P2, P3, P4 and P5. Okay, so we are done with this. So I have just told you that sum is a member of an object, while display is a member of the class. So the dot or dereferencing operator called dot basically is that. Now, is there another way of doing this? Can I write this as rect? Okay. We will see this referencing in a different way. Let it be a dot operator for now. So P1 dot sum I'm calling with out P5. So the P5 will have the result, which will be summation of P1 and P2, and P3 has a result which is summation of, or P4 is the result which is summation of P1, P2, P3. So just build the solution and just say debug, start without debug. So let's see this. There are 3 points, P1, P2, P3, and this is summation of this. So basically 6 plus 3 is 9, plus 2 is 11, that's 1. And 1 over here, 5 plus 4 is 9, 1, 10, 10.1. And then this summation, 2 plus 2 plus 2 is 6, 8 plus 4 is 7, plus 1 is 8. So this point, the fourth point is a summation of P1, P2, P3. How about the fifth point? Fifth point is 3 plus 2 is 5 and 2 plus 2 is 4, so it's 4.5. 2 plus 2 is 4 and 3 plus 4 is 7, right? So this is 4.5, 3.7. So basically I have used a out parameter, right? I have used the out parameter to get my results. I can create as many out parameters as is. So a method does not need always to return one variable. It can return more than one variables, and you can use out to do that. Now there is another method of doing this which is called ref. So what is the difference between out and ref? Out, okay, is not created prior. You see, P5 is not created prior. This is just a placeholder, okay, but ref has to be created prior before passing it. So basically this is by a placeholder, this is returned by value, while if I use a ref here, okay, so if I was to use a ref here, Okay, so it is complaining. It is saying you are creating a ref, but then this is a null pointer because p5 is not created yet, right? So in that case you would have to do a rect and then p5. So this is passing by reference now. Okay, and then you can say new rect, and which is an empty structure. Now that is being done, and here I have to refer to as ref, and that means that this creation is not required because you are already receiving a reference to or a pointer to this object. uh, uh, I don't have to create it. Now it's okay. Okay, so ref is first created here and its referenced is passed here. So this is passing by reference, and this function receives the reference and returns the result in that, and this is going to behave exactly the same. Only thing is that the ref, all the variables which are reference types, they have to be created prior to you are calling them, right? So you are passing a pointer to those variables. First you are creating and passing the pointers. You can pass as many refs as you like, right? So this is the difference between out and ref. Out is just like a placeholder. It is like a passing by value. So basically you have to create here out, okay, because the out is not created anywhere, right? So you have to create the out inside the method itself, while the ref is created prior and you have to just use the reference, right? So that's the difference between ref and out. So is this going to work the same way? Build solution, debug, start without debug. So it works the same way, right? Okay, so we have put that out of the way. So now one more point to notice is, in case of polymorphism, ref and out do not participate in the signature of the method. So you cannot make the signature unique by using ref and out, which are different, right? So you have to have a parameter list which differs, and this basically the exception is you cannot use ref and outs. And what is the sequence? You should have first refs and outs, then the parameters, and then params. So whenever you create an argument list, okay, it has to be first a ref and or a out, or ref and out mixed together, then you followed by the parameters you want to pass, or in the argument list the other parameters, and finally you can have params where it is a an array of arguments, right, which you pass. So all three can be mixed. So this is how you basically write the methods. Again, methods can be members of the object where you don't have a static here, or whenever you put a static, there can be methods of the class or a structure or a type, right? So that's the difference. And the third thing which I have shown you is the overloading of the operator. So this is about that. Now I don't want to make a separate video for another data type which is called enumeration. So I'm going to very quickly show you another type which is called enumeration here in itself. So let's say I create enumeration, and I call this enumeration as my color, and that basically is a list, okay, and that list is red, blue, and green, and an orange, right? So my color basically is an enumeration. It can take value red, blue, green, and orange, but the base type here is an integer, right? So the base type here is an integer. Now integer has got 4 bytes, and the position holders say you know, this value of red is going to be 0, blue is going to be 1, green is going to be 2, and orange is going to be 3, right? So let's see what you mean by that. So over here, let me just do this. My color, and let's give a shirt color. So this is an object of that enumeration type, is equal to my color dot red, correct? And then I can say console dot write line, console dot write line. I can say my, we put here a dollar, my shirt color is, and here I am going to put that, and here it will be shirt color. Okay, so what do you think it's going to return me? It's going to return me red, right? So I'll just save it, and I'll just build this solution and debug it. So my shirt color is red, but red has a base type which is an integer. So let's see that. How about I was to cast this, because it is an integer, right? I can cast it like this, isn't it? And just say build solution and debug start without debug. So my shirt color is 0. So red basically represents the position it is holding. Now if I was to make it blue, then it will become 1. So blue, if I was to build the solution, start without debug. So my shirt color is 1. So 1 basically is the value of blue, right? So you understand that. Now can I change any of the sequences? So if I was to make this one as 10, so now the blue would be 11, green will be 12, orange will be 13. So this should put out 11. Build solution, debug start without debug. So it puts out my shirt color is 11. So you understand that. Now can I, okay, let's put green, so that will be 12, right? Okay, so green would be 12. Build solution, debug start without debug. So my shirt color is 12. So green is basically taking the value of 12. So the way it goes is 10, 11, and 12. Now what if I made this one as 10 and this one was nothing? So it will start with red is 0, blue is 10, green is 11 now instead of 12, and orange as 12, right? So green would be 11 now instead of 12. So build solution, debug start without debug. So now you see that the green is not 12, it's 11. So you know how the numbering is done. Okay, now can I basically, does it have to be monotonous? No, I can make this as 0 again. So now red is 0 and green is also 0. Build solution, debug. So it's 0. What about red? Red is also 0, right? So let's make this one as red and build solution, debug. So now red is also 0, right? Okay, so what I'm saying is that you can put any form of it. Now what about I don't want to use an integer, I want to use a byte as a base type? So I can do that as long as these values fit in here. Now what if this one was 253, sorry, 253. Now byte can hold 253, byte can hold 254, and byte can hold 255. Now let's make this as 254. So see, the orange is in problem because now blue is 254, green is 255, and orange is 256. Now 256 is out of the range of the storage, which is byte. So basically this is checked as a overflow. That's why this is showing as red. So you understand that you have to make sure that the entire range has to be, has to fit into this type here. Now if this was an integer, which is by default, then there is no issue because now it can have 254, 255, 256. But if it was a byte, this will not work, right? So I hope you understand that you can change the base type, but you have to make sure that you sit in the entire range of the enumeration sits or fits into whatever base type is over here. Now, can I use this in switch statement? Yes, I can. But the only thing you have to be careful is that you should not be repeating the values. So for example, if I was to do red equal to 0 and if I was to do green equal to 0, now can I use this in switch statement? Answer is no, because red and green are not unique. The switch statement will be confused, right? So having said that, whenever you use enumeration in case of a statement like switch, this has to be unique, right? All the numbers have to be unique, otherwise you cannot. Now can I do something like this? Yes. So red will take a value of 0, blue will also take a value of 0, green will take a value of 1, and orange will take a value of 2. Now can I do this, that the red is equal to blue and blue is equal to red? Answer is no. So this cyclic assignment is not allowed. So this is a cyclic assignment. Okay. So this is perfectly fine, right? I can also do green equal to blue, and I can do orange equal to green. Now that means that all of them are 0 now. Red equal to 0, blue equal to 0, green equal to 0, orange equal to 0. So enumeration goes like that. Okay. So this is enumeration is just like a list, but list is slightly different. We'll cover later on. Array list. Okay. So this is enumeration. It's a type. Okay. Now there is another thing which is called tuple, and a tuple is basically a list which is immutable. Immutable means just like a string which is immutable. When you create a list, you cannot alter that list. That means it's immutable. Okay. So let's see what do you mean by that. So let's say over here I want to create a tuple. So I can do a var, and I can do nums. So this is a tuple, and tuples are usually inside this small brackets, and I can say here 1 comma 2 comma 3 comma 4. Okay. So now here this is again a kind of a ordered list, but it is immutable. It cannot be changed. Now how do I access the members of this? So I can say console, for example, I can say console write line, and I can print here nums dot item 1. Okay. Can I do, the base type is still an integer, so I can do all the operators which work on an integer, right? So this is similar to enumeration, but this is a tuple. A tuple basically is just like enumeration or just like a list, array list, but it is immutable. It cannot be changed. What do you mean by that? So let's say now this is item 1. Item 1 is 1. So let's just debug this. Okay, so it is going to print 1 here. So that's item 1. How about item 2? Item 2 in this case is going to be 2, right? Or I can put here 5. Let's change here and change it to 5. So item 2 is now 5. Build solution and debug, start with our debug. So it's printing out 5. Item 2 is 5. So this is how you handle a tuple. Now, instead of doing item 1, item 2, you can also name them. So I'll come to this later. But let's see if I can alter it. So can I say nums dot item 1 is equal to 2? Can I change this tuple? Uh, this is acting as a array list. Let's see. Let's put here item 1, and let's put here item 1 again. Let's see, item 1 can be replaced. I think it can be replaced. Okay, just like a string, it can be replaced. But can you add another item to it? No, you cannot add an item to it. That means immutable. Okay, so first it was 1. Second time it has become 2. So basically you can change a value in a tuple. But can I add another one? Is there something called add a item? So can I do nums dot add? So you do not have an add. So basically you cannot change the size of a tuple, right? Okay, so when we come to array list, we will see what do you mean by immutable. Tuple is non-immutable, which means that though you are able to change the values inside it, you will not be able to add another item, or you will not be able to delete an item from that tuple. Okay, now let's see if I can refer to these by names. So can I have a tuple assigned to a tuple? So I can say here red comma what. So let's give here a different name. So this is a base type integer, so I can say int a comma int b int c int d. Yeah, so now is item 1 valid? Let's see again. Nums dot, so item 1 is not valid. Now you have named it as a b c. So you have a, and then you changed a, and then you printed a again. Okay, so I am basically calling them, instead of calling them by item 1 2 3, I'm calling them with the names here. Okay, so build solution, debug, start with that debug. So 1 changes to 2, so that's fine. So basically that is tuple for you. Okay, now another thing is arrays. So I will cover arrays in the next session, because I have already, I think, exceeded 1 hour, right? So I will do arrays in the next session, and then I will look at some of the properties of string. So basically that will cover various types. Then the other 2 types are delegates and interface. So in the next session I will cover delegates and interface. So with that we'll be done with all the types, right? And then we'll move on to more complex topics like collections, right? So thanks a lot. Thank you very much.